Hi folks, today's video is about IR remotes. There's hundreds of videos about IR remotes, and they all get excited about Manchester coding and all the bits and that sort of stuff, and it occurred to me, this is kind of a cheap trick. It's really not necessary to know all the digital codes and things. All you have to do is record the waveform and then play it back. So let's see if we can do that. I think basically this is all you have to do. There's a little IR receiver module. It only costs $1 or $2. It's a 3-terminal device, runs off to 5 volts from an Arduino clone. Needs a little RC filter on the power, and the signal goes right in to any of the digital pins in the RD clone. You can have the handheld remote, that's the regular remote, and we're going to make a copy of the code and put it in another Arduino clone. All you need to drive, any digital output can drive a little current limiting resistor and an IR diode. Neither one of these things will drive the receiver. It would seem that all we have to do is have a loop where we wait until an interrupt comes, a signal comes and makes an interrupt, and record the time of it. And I'm going to count off, I have an array of 100, so we'll save 100 of them. If you don't have 100 yet, you wait for the next one, and you wait for the next one, and when 99 comes, you dump it. You take all those times and put them back in the transmitter, and the transmitter, all it has to do is read the times, flip the cents, because the remote's going to go from 1 to 0 to 1 to 0, and the signal's going to go 1 to 0, 1 to 0. If the signal's 1, you have to make the pulses as required. If the signal's not 1, you have to make a delay of however long the delay is. So it depends on what the sense of the signal is that you're making. Now, this is roughly what the signal we're talking about looks like. Our remote protocol is a batch of pulses. It sends pulses. This is the Manchester coding thing, but basically there's pulses, and then there's blanks, and there's long pulses and blanks, and the pattern of the longs and the shorts is what makes the signal. The IR receiver module just puts out that waveform. It's inverted. This is shown as positive, and the receiver module goes negative. So basically the code message starts off with like a 10 millisecond start pulse, and then the long and short delays for about a 65 millisecond total length. Now when it repeats, if you just hold the button down, it automatically repeats every so often, but the repeat signal does not really repeat the code. It's a special signal that says repeat with these kind of timings. So that receiver signal goes in to the clone, and the interrupt is used to grab the clock time of that signal change. And here's the little receiver module glued to a piece of plexiglass. The circuitry on the receiver board isn't much. That's the resistor and capacitor for the little filter for the module. And if we just take the remote and push the power button, there goes the waveform. Okay. This is the little breadboard of the transmitter, which, as you can see, doesn't have much except for the current limiting resistors, and where is it? I put the LED itself in the end of this little straw so it's easier to aim. So here's the little machine set up on my tripod, pointed at the receiver module over there, and sure enough, every once in a while you can see the message pulse come up, followed by the repeat pulses. Now we'll take it over to the TV. So here we are with it carried over in front of the TV, and the LED in the straw, and TV goes off. 6 seconds around the loop, bang, TV comes back on. So I guess it works. It's nice to have the straw to help the pointing. This thing does have a rather narrow beam width. This is what the delays look like if you load them into a spreadsheet and put them on a graph. This is the name of the switch, name of the button. This column is the microseconds of the actual delay, and this column is how many pulses it'll take at the 36K carrier rate. So the first part here, this is a 99 interrupt collection. The first part here is the actual message, and then you can see it goes into the repeat pulses, which are greatly different in delay time. This is an expanded version of just the message part to show the different levels of delay. And of course, as you go across here, the state's going from 1 to 0 to 1 to 0 to 1 to 0 to 1 to 0 at those delays for all the buttons. This is the receiver software. After the declarations, pins, and so forth, the setup routine sets the pin mode, starts the serial comlink, zeros the delay register, and then attaches the interrupt from the digital pin that you're going to receive the signal on. OK is the interrupt handler, and change, the interrupt will happen every time the signal sense changes. Now, the loop is basically just a wait. This is a little routine to just count seconds, and the blink blinks the LED. Both these execute very quickly. So basically, it just gives the loop something to do while it's waiting for the interrupts to happen. The interrupts happen, they're not shown in the code, they just happen. And when an interrupt happens, it runs the interrupt routine, service routine, and it counts them off. By the time you get 99 and you fill the data array, you go to dump, or else you just go back and wait some more. When you dump, what you do is first cut off the interrupts so they stop changing things. And if you only want to do it once, you can do it once. Or if you don't do it once, it'll do it over and over and over. And all it does is print out the delays and loop. Now, the interrupt handler routine itself, oh, ignore this. This was a early try that was way too fancy. All you need to do is count the number of times you've had an interrupt, put the time in the delay register. I also record what the sense of the interrupt signal is in case you need it, and that's it. Go back to the wait loop and wait for the next one. Now the transmitter routine is simple too. Here's the array for 99 interrupt times. The setup routine is nothing special, starts the serial routine and loads the message that you were going to send. The easiest thing to do, let me jump down to that. The easiest thing to do was I have a terminal program, old terminal program, that just record the serial printout and load it in directly to the delay array. These are the pulse counts required to make the time intervals. 100 long. And if you want to print it out, you can print it out. But basically, you have the array of 100 pulse counts between the interrupts, and you want to do one of two things with them. You either want to send a certain number of pulses, whatever is required to make the next delay. This little routine here executes in about 26 microseconds. It just sets the pulse pin high and then sets it low with little delays. That's the proper timing for the 36 kilohertz. If you're going to send zeros, you don't need to send anything. All you need to do is delay 26, come back. So that's the transmitter. That protocol chart, that must at least be 20 years old. And I must have a half a dozen, maybe a whole dozen of remotes lying around, and there's differences between them, and the protocols evolved over the years, and manufacturers adhere to as much of it as they want to. So my advice is, if you want to experiment with this sort of stuff, use that spreadsheet and look at the delays that you actually get from the buttons that you actually have before you design too fancy a program to measure them. Okay, thanks for watching.